The crash which you have just seen from moment of impact until the vehicles came to rest took 3/10 of 1 second. In about the same time it takes to puff a cigarette, an accident has been recreated and the results have been recorded. The measurements, the data collected from experiment number 220 will affect the thinking and planning of the many specialists who make up our research staff. The crash teams, the engineers, the scientists will interpret their findings for the designers, who must build a new concept of injury prevention into the cars of tomorrow. We'd like to give you a brief picture of the planning behind this concept and the work that goes into these full-scale crashes. What happens in that important 3/10 of a second, and how we measure results. We can't seem to find many volunteer drivers, even among our dedicated engineers, and that's why we tow the cars into the crashes. Here's a diagram of a typical crash. The crashing car is towed and released just before impact. Running along the side of the crashing car is the instrumentation truck, connected by some 16 instrument cables that carry the time and force messages to the sensitive measuring devices in the truck. Our towing car is equipped with a fifth wheel, which gives us an exact speed figure. Here you see the tow cable release being checked. Our crashing car is of particular interest because in many ways it's quite an unusual automobile. First, the occupants. On the outside, they're fairly normal, 6 foot, 190-pound adult males. On the inside, they're equipped with electronic devices and contact points that are going to tell us when and where they have been hurt and how they feel about it. The cars are equipped to test a number of safety devices, which have been and are being developed. Certain of these test vehicles are equipped with safety locks, which are designed to reduce the chances of passengers being thrown out on the pavement, where their chances for injury are about doubled. We have tested and retested the necessity to treat other critical areas. Safety glass rear view mirrors, sun visors, and the advantages of padding instrument panels. Another area which has always been a problem is the steering wheel. So many of our test cars have safety dish-type wheels that are designed to catch the driver like a catcher's mitt and cushion his fall forward. Remember that not all the crash cars are fully equipped with safety gear. We have to measure the results with and without to get a true picture of their value. And that's where our measuring devices come in. We must know exactly what happens to our passengers in that critical 3/10 of a second. And since none of us is going to sit in the back seat and watch, we rely on several high-speed camera films, our 1,100 feet of cable, and the equipment in our instrumentation truck. Some of our cables are, of course, attached to our passengers. They also tell us time and force ratios on the front of the car, under the car, the visors, seat belts, and so on. All the areas that can give us facts. These impulses are transmitted directly to the amplifiers and oscillograph recorder that tell us to the thousandth of a second what happened and when. This camera record slows down our action more than 20 times. This is the same crash you saw earlier. Here's the view now from the back seat. Neither dummy wears a belt. Watch the rear view mirror and the visor on the right. This was a fairly common medium speed accident. Now let's see the same type of crash without safety locks on the doors. Watch that door. And here it is in a four-door in slower motion photography. And again, the door pops open. Records like these prove that safety locks are an important part of tomorrow's safer cars. Here, in even slower motion, is exactly the same type of impact with safety locks. This 35G barrier crash is designed to break test equipment. Fortunately, it represents less than 5% of total accidents. These next three sequences are simple broadside impacts that occur all too frequently. The first, at slow speed, pushes the victim car sideways approximately 3 feet. Here, a little faster, we move the car about 6 feet. And note that our dummies, without seat belts, reacted more violently. Finally, faster yet, we see a more serious accident. Our dummies give us an even clearer reaction in this approximately 9G crash. Our second car moves sideways about 16 feet. Here now is a sequence illustrating another kind of impact. Here it is again in slower motion. The dummies in the crashing car are not wearing belts. The other car has safety door locks. This dummy keeps his seat because he's wearing a seat belt. And from the back seat of the moving car, we get a different picture. The crashes you have seen are a spectacular and exciting part of our job, but only a part. We don't like to smash these automobiles because they're expensive, but this is the only way to simulate the actual conditions which can establish the design criteria so that we can achieve this new concept, a safely packaged passenger. There are many things we don't know, and we're still looking for many answers. Our goal is reduction of passenger injuries. We're on the right track. And when Test 520 and 2020 have been recorded, analyzed, and evaluated, you'll be riding in a better and safer car.